which design pattern is the best design. So that is the query. So all design patterns are best design. Now it depends that where it is required. Like there is a simple creational design pattern called prototype design. So has its own importance, or builder design pattern, or abstract factory or factory method, or if you see the structural, then composite design pattern to facade, all are decorative, all are equally important. But few design pattern they talk about intermodule interaction, how two modules, n module, they interact with each other. Okay, so uh, the two design pattern that comes into the picture is mediator and observer design. Okay, so these two design patterns, that is a kind of they look similar, but they are highly different to each other. If we go kind of little close when we see the design patterns, and there are two different worlds. If we see the observer design pattern, it is also called model view controller design. So observer design pattern generally it is used when there is a many one relationship is required. Means one module to many modules like broadcasting. So that is the place where observer design pattern is. Like there is one data and there are many views to it. So there is a one data and there are many views to it. Like there is an auction going on and auction for a bicycle. Means there is a bicycle that is kept. It is probably very good and there is an auction is going on. If someone says that it is 10 unit of money that I am going to pay, then if 10 unit of money is higher than whatever the rate of the bicycle, then it will be written as 10. Now 10 is broadcasted to all the viewers, all the observers. So subject is the bicycle 10 unit and all the observers sitting there. Now they have their own views of the 10. Now suppose that everyone is journalist and they are broadcasting the on their own televisions. Now the $10 or 10 rupees or 10 unit of the money. Now it is being broadcasted. It's an old view. Someone is showing in tabular format that every time to time how it is changing. Someone in pie chart and someone in histogram and someone in this chart, someone in that chart. So view as per the observers are different, but data is same. So where one data is there, one to many relationship is required, then we use a kind of observer design or model view design. So here each observer is kind of they keep pointers to the data, and whenever data and data, not only observer and the data. So, or rather, we can say that the data that is subject, it gives the pointer to all the observers, and whenever data changes, then it forms all the observers. So there is a data class object, and all observers are there, all views are there, and it keeps the kind of just loosely, not composition pointer, kind of delegation, kind of aggregation pointer, or loose composition. So it keeps a weak composition, weak references in Python terms. So the data, it keeps the pointer of all the observers. If there is any change in the data, then it notifies all the observers. and they change their views. They are showing in different formats and they change their views. Now, any of them can stand and can say that a 20 unit means he is kind of making auction or the bicycle as 20 unit. Now 20 unit is more than 10, so it will be so data changes. Now if data is changing, then all views will be notified in a broadcast manner that this is the new data, no interaction, just information. So one-way communication, one communication to modify the data, and then all the communication to the all the observers, they heed to it or they refuse to listen to it is up to them. So it is just a broadcast. So these kind of loose scenario is good in MVC design pattern or observer design. So look at a scenario where there is one tower that is maintaining all the aircrafts. So there are 100 aircraft or 50 aircraft that are kind of they want to land on an airport, and now one is saying that I want to land on the airport. Then the tower, the person who is sitting on the tower, he is maintaining the data. Now he listened to the data that one particular pilot is saying he's want to now uh, get down. Now he'll broadcast to all the pilots. Doesn't make any sense. Means here broadcast is not required. Like siren kind of situation. If there are many observers to a particular event to happen, an event happens, then all the observers should be notified the event. Everyone can take different measure, depend upon the event. Okay, like uh, there is some power outage. Okay, so there are three phase of wire is going on. In particular phase there is a power outage. So if there is power outage going to happen in next 1 hour, then operator would inform all the users the next 1 hour power outage would happen. That is the broadcast. Now all the users they are doing their own work. Now they will take action as per their own. But in the radar system, if one user wants to, one pilot wants to get out, land their aircraft, he informs the person who is maintaining the data at the radar center. Then radar center guy would not inform all the pilots that this pilot wants to kind of land. Doesn't make any sense. So here, the observer design pattern differs from the mediator design. Observer design pattern, mediator design. Mediator design pattern where many to many relationship is required. Okay, like I am playing a game where there are two people. One people on one side, two people. Other side, two people. That can like badminton. Badminton, two people are playing on one side. Other side, two people are playing. Captain is not required. Means if something happens, then they talk to each other. Okay, so a straightforward communication. But like game like football or soccer, where 11 players are playing, they cannot communicate to each other for everything. Means one player communicates to 10 players. Again, one player communicates to 10 players. Again, one player communicates to 10 players. How many combinations will happen? It will go more than 1,000 or 10,000 or lakhs or millions whatsoever. So that much combination, when many to many relationship is required, and that way of module communication is one to many observer design pattern, but many to many. Like I have a graphics where there are so many user controls are there, button, edit box, and then kind of radio button, and then we have a scroller, so many things. If I change at one place, few of them may change, not all. Few of them may change. If I change something, then one of them may change. So it's a many to many relation. If there is only two, then we can write the code. If there are 100 user control, then for all 100, writing a mesh is not possible. So if these kind of scenarios, we need a mediator. So A mediator is a kind of a guy who sits in between. So all the entities are spread and one kind of logic is placed in the mediator. They are connected to mediator. Mediator, mediator keeps pointers to all the items. All the items keep pointer to mediator. In observer, everyone is not required to keep pointer of the observer. Means whoever want to change the all the observers, they may not need the pointer to the data subject, but subject need pointer to enemy. It has to broadcast. The observer who need to change the subject, they only need to keep the point to the subject. But in the mediator, all the objects they need to keep pointed to the mediator. Mediator need to keep pointed to the all the kind of all the modules. Now, if any module is want to change something or data that is maintained by a mediator or it does anything, like user clicks on something, then it would do the work and it means whatever work it can do on its own and it would inform the mediator. Now, mediator knows that who to inform. No, so that is the scenario. Like in the aircraft system, a pilot wants to communicate anything. He would not communicate to all 50 pilots. He would communicate to a mediator that is standing in kind of radar center, and that person would take decision that what it has to do. How if he guides that pilot to come to a level or go up level, go in this direction, that direction, then how a particular other pilot or particular five pilots they need to be informed because they would be affected by giving any decision on this pilot. So these places we need mediator design, or we talked about the graphics, or we talk about the soccer or football match. If a player is playing, then captain is watching, captain is mediator. If he feels that the based upon the person or players play to other players, they need to be made attentive because the way he's playing, he would kind of do some kind of signaling. So those two players they get ready, means ball would come to you or something like that. Or if a player has some problem or he pushes some suggestion, he needs some suggestion. He's not going to assemble all the 11 player and he talk with everyone. He'll just connect to the captain, and captain knows that how suggestion can be resolved, or he need two more player to come, or he need to communicate one more player, or he need to communicate to the coach. So this kind of information where entities are many and they need to communicate with each other all possible ways. Then we introduce a new layer called mediator. So mediator has the laws. So mediator is kind of smart. This can be considered as a hardware level of switch where one interact with others, or router means router is a mediator, means it has logic. When data comes in, then it thinks where data should go. It should go to two other routes or one route when it should go. So logic we place in the router, logic we place in the mediator. Mediator is connected to every entity. So this is the module-wise communication as far as design patterns is concerned. So in design pattern, how we can manage module-wise communication. If one to many is required, then we go for observer. Many to many is required, then we go for mediator, where mediator is another guy which comes into the picture, connects to everyone, and everyone they communicate their sentiments to the mediator, what they have done, or what if they need anything. Then mediator is the guy who fulfills the demand. So these are the two primary design pattern in intermodule communication. It lies in behavioral design pattern. Very close. Means if person understand the intricate need or intricate design of these two, life is pretty easy.